guys. All right, so now that you've learned about like what hypothesis testing is and the general information, let's do some hypothesis tests. When we have a large um when we have a large sample, then we're going to use the z-test. And remember the z-test, you need to see the words population, standard, the standard deviation of the population. All right, so again, here's the steps. We're going to do those steps. It's a lot of writing, so it seems like a lot, but it's not. Okay, all right. So we have this, like the test value. This is spelled wrong. It's going to be like the z-score, but the newer formula because of the central limit theorem. So we're going to take the observed value, the mean. We're going to subtract the other way around. We're going to subtract that boy, yeah, the other way around. Well, I don't have you memorize formulas because I can't remember them. Okay, we're going to take the value they give us, the mean, and then the standard error, which was standard deviation over square root n, okay, to find the test value. So we can go through all that, and then normally we're going to be dealing with the mean. With the z-test of a proportion, you're doing a proportion versus the mean. All right, and so we can go through pop it in the formula, go look it up on a chart. This would be, go look it up on a chart. This would be popping in the formula, and then we make a decision. However, I think it's kind of like an important skill to be able to use technology. Not because it's faster, but because it does not matter. If you're working at McDonald's, if you're a secretary, if you're a nurse, if you're an engineer, if you're going into banking, it doesn't matter really what it is, okay? You need to be good with technology, and you need to know how to use technology regardless of the kind of technology that it is. So regardless, or that you need to have the skills to be able to look up something and then use that technology, or have the confidence and the ability to ask for help when you don't understand the technology. All right, so that's why that's why I use the calculator. I know that you might not need the graphing calculator in whatever job you're going to have. However, to be able to analyze data, you will, regardless of what job you have, and to be able to use technology, excuse me, and the interface, that's a super important deal. All right, so instead of going through and looking it up on a chart and doing that, excuse me, formula, we're going to use a calculator. So to get here, to get to this spot, we're going to push stat, we're in statistics, and then we're going to go over to test. And then we're doing the z-test, okay? If you have a list of data, then you're going to highlight the data piece and put it in like list 1 or something, okay? If you otherwise, like the problem will give us all this information, and we just pop it in, and then we're going to go down and click calculate, and it will pop out like the answers, and we have to know how to analyze the answers. That's what I care about. All right, so here we are. we read the problem, I'm gonna write down the information. In Pennsylvania, the average IQ, right, 105, is normally distributed in population standard deviation. That's how I know I need to use the z-test because it says population standard deviation. All right, so that one is 15. A school superintendent claims that the students in her school district have a higher than average, so higher than average IQ. All right, so that's what she claims. That means that's the alternative hypothesis. So the null hypothesis would be that guy. She selects a sample of 30 students and finds the mean to be 106.4. Test the claim at alpha is 0.05. Okay, so I'm going in my calculator. I go down to z-test. All right, I'm going to highlight the stats because they just gave us all the information. All right, so u-naught that's this guy, 101.5. This, remember, is standard deviation, so 15. X bar, that's this guy, 106.4. In, that's in, okay, right there, it's 30. And, okay, let's look here. It points to it points to the right. All right, so here we are. Okay, make sure it looks like that. All right, and so this information, I'm going to just write down. Okay, and so we're using the z-chart. Let's hang on one second. Okay, sorry, I was doing this problem and I realized I didn't tell you something kind of important. All right, I want to pause this problem because I forgot to tell you something kind of important. All right, when we okay, when we compare the test value and the critical value, on this right here, compute the test, we're going to use our calculator. Okay. When we find the critical value, we need to use the appropriate table or chart. And so if we're on the t-test, we would use, if we're on the z-test, we would use the z-chart. However, the z-chart is super symmetrical, and so the same values are going to come up every single time. Okay, and so there's a little writing on this, but you'll get the point. All right, so if it's a left tail, this is also like in the notes answer key, there's a clear version. If it's a left tail and, I don't know, alpha is 0.005, then the critical value is going to be negative 1.65. Okay, and so that's how we read this chart. If it's a right tail and alpha is 0.01, then the critical value is 2.33. If it's two-tailed and the alpha is 0.1, then there's two critical values because it's two-tailed. And so you get one negative 1.65 and one positive 1.65. Okay, notice that here, these values are the exact same as the ones we learned for the z-test before. And these other two are slightly different, okay? All right, so you don't necessarily need to memorize these, just have access to them. Okay, so here we are. We had figured out, the calculator told us that the z was 1.79, all right? And we need to compare it to something. All right, so we have alpha is 0.05, and we have it's a right-tailed. I'm going to go back to that chart. Right-tailed, 0.05. So I get 1.65. 1.65. 1.65. Okay, and so my critical value is 1.65. All right, so I'm going to draw this out. The mean, 1, 2, 3. So 1.65 is here. And I'm going to shade there. Okay, and so then I need to compare this 1.79. All right, 1.79 is right there. It's in between 1.65 and 2. And because it's in the shade you reject the hoe. You should always reject the hoe, by the way. Just kidding. I mean, well, you know, okay, you get it. All right, so it just matters if I make myself laugh. All right, and so we're going to reject the hoe because it's in the shading. If we had, I don't know, negative 1.79, that would have been over here, and so we would have accepted it. And so because we reject this guy, we reject the hoe, that means we totally accept this. And so we would say, therefore, there is enough evidence to reject that the mean is 101. All right, you could also say, by the way, therefore, that's what this means right here, therefore. You could also say, therefore, there's enough evidence to accept the fact that the mean is higher than 101.5. Right, so you could get the same information across just a different way. All right, so here we are. Whew. We're going to do this problem, and notice we have a list of data. So the first thing we need to do is just stick that in our list 1. Okay, and so I'm going to do that. I hope you're doing it with me. It does no good if you just watch me do the problem. Like, you have to practice. You can't just watch somebody drive a car. Like, you have to practice. Alright, so I typed it in and I put it in list 1. Now let's read what they have for us. Specific year, the average score on the SAT math was 515. The variable is normally distributed, the standard population, standard deviation. Alright, so that's how we know we need to use Z. Okay, that guy is 100. The superintendent, from the problem we just did, wants to see if her students scored below the national average. Alright, so this is the alternative, H1. And this guy right here is the null. He randomly selects these students, and where alpha is 0.10, there are 1, 2, 3, 4, 5, 6. 1, 2, 6. So there are 36 total. All right, and so I'm going to go to just stat, test, Z. We have data. And so I'm going to write 515 for my U-naught, 100 for my standard deviation. My information is list 1. Okay, and I'm going to go to calculate. And so it gives me information. Okay, I need to stop this video, and in the next video we'll analyze.